Okay, this is activity ZZ09 and we have a rotating arm. Actually, we did this problem earlier in the course, and there I assumed that the rotational speed of that arm was constant. So it was fairly straightforward to write the expression for the angle that it sweeps. You know from basic physics that the angle that it sweeps is equal to angular velocity, omega, times t. However, what we want to do now is write a more complicated variation of the angle as a function of time. For example, in the first 3 seconds of uh, of the motion, the angular velocity is constant, as you can see. The slope of that line in that period 0 to 3 seconds is 180 degrees in 3 seconds, or 60 degrees in second, and then the angular velocity becomes zero because the arm stays stationary, remains stationary, and then after 7 seconds, again it starts to move. So we cannot write this in a simple single line. We have to write a few lines of code, and we started doing this thing in the previous activity where actually block was traveling along a track. Okay, so let's go ahead and do this problem. It's very simple model, so I'm going to insert my first part over here. I'm going to call it the base. Right click properties, base and base, base and base. Okay, let's go make it. Double click on this. On a convenient plane, on that horizontal plane, I will sketch a circle and then pad it. That's going to be basically the foundation of this arm. There we are. Fine. And now we're going to insert the arm. So all the way on the top, insert new part in there. I'll call this thing the arm. Properties, arm, and arm. And arm. Okay. All right, let's make it. On a convenient plane, on that top plane, I will sketch something that resembles kind of that arm. Maybe something like this. Okay. And want to make these things concentric. This control that, can I make it concentric? Okay, cancel. You got to be careful here. Cancel. Why don't I make this thing and this thing tangent to each other? Okay. And here. So that's fine. Exit. Add it. Fine. Okay, good. All right. And all the way to the top, file save management. I have a folder there, ZZ09, right? I'll put stuff in there. Okay. Now, let me go to the assembly design. So I'm going to anchor the base, and then coincidentally, this axis and that axis, and coincidentally, this plane and that plane, that makes it a revolute joint. Okay, very good. By the way, if you don't want these things too tall, you can double click on it. Maybe I'll make it a little bit shorter, maybe point 4, point 3. Yeah, that's more like what we have in the diagram. Okay, now we're going to go to the digital mockup. So that's digital mockup, DMU kinematics. Get the magic wand out. New mechanism 1, auto create, and it's going to be a single revolute joint. See that? Of course, if I make degree of freedom, this make this angle driven 0 to 360. Of course, mechanism can be simulated, and you can do that manually if you want. Okay, good. All right. Now what we want to do is to put some physics into the problem, and my physics is that this angle is equal to velocity times time, but the velocity, as you can see, is not constant. So basically, you have to write a code, a simple code, and let me remind you how that is done. So you're going to go to Start, Knowledgeware, Knowledge Advisor, click on this icon which says if X, Y, basically a rule, make a rule. Okay? And the name of this rule is whatever you want to do it, the date and who wrote it, etc. And now we're going to look at our graph here and try to write the lines of code. So let's go there. Oops. That's the header. This is basically, this is a comment, right? Slash star, slash star. Okay, so let's do it here. If time, now we're not interested in all the stuff. I'm interested only in the things that's related to mechanism, and it's only these things, okay? So if time, there we are, I selected this, double clicked on that, puts it up there. If time is less than 3 seconds, I believe that said 3 seconds, right? Less than 3 seconds, velocity is 180 seconds divided by 3 seconds. So that is basically writing it like that, 180 degrees divided by 3 seconds. Or you can write it as 180 divided by 3 times 1 degree per second, okay? Or something like this. So let me go here. Let me write it like that first. Angle, so this is angle, add a formula, or not add a formula, equal to, not add a formula, don't add a formula, equal to, uh, let me write it several different ways and show you that you can't just recklessly go ahead and put something that looks reasonable. It has to be consistent with the syntax in whatever the C programming is in Catia. So for example, can I write it like that? 180 degree divided by 3 seconds. The answer is yes, I can write it like that. And just to convince you, let me say okay here and see whether it gives you an error message. Units are not homogeneous. Let's check out. Oops. Let me see. Let me see for a second. Something was not. Okay, so let's see now. This is oh yeah, of course, times time. Shoot. Times time. Of course, units are not. This left side is degrees. This is 180 degrees divided by 3 seconds. But if I multiply it by time, then I should not get a syntax error. You see that? Didn't get it. Now, let's go back here. Let's do it a different way. 180 divided by 3. I'm writing it like that. DEG underscore S. Let's see if this thing works. No. But if I wrote this thing as times, I need a 1 because even if I say okay now, I get a syntax error. Say yes, I want to go fix it. Times 1 degree per second, I should not get a syntax error now. You see this? You have to be very careful. We discuss these things in the first tutorial. Okay, so you can write it like that if you want. And that's what these things are for when I say here, it's referring to this stuff. Now here, of course, I've done it as in a long way, 180 degrees divided by 3 seconds, times time, etc. But it's done written it differently here. By the way, The fact that you're not getting syntax error doesn't mean that actually you're inputting the stuff correctly. Later on, we're going to plot the command, and I better get something like that. I better get something like this. Just because you're not getting syntax error doesn't mean it's right. Else, if time less than, just look at your graph, less than 7 seconds. 7, don't forget the S, otherwise you get syntax error. 7 seconds. This angle equal to 180. Don't forget the DEG, because during that period it's 180 degrees. Okay, and then else uh, time. Well, I don't need the time anymore. Obviously, that's more than 10. Else the angle equal to 180 DEG plus, let's see now, what do we have here? We have another, 180 degrees in another 3 seconds, okay? So here we go there, plus 180 divided by 3 times 1 DEG underscore S times, not time, okay, it has to be time minus, times, let me make this thing longer. Don't forget the shift. Oh, it's not right. Okay, this is all nonsense. Times time minus the 7 seconds, 7s. You need the shift. You have to consider the shift. Make sure parentheses and everything is okay. So if you look at my, you'll see you have to write the shift there. Otherwise, you just sit down and work it out. You see that doesn't make sense. It's not right. Hopefully, there are no syntax errors here. So we say, okay, there are no syntax error. So we're going to go to simulation with laws. Simulation with laws. Click on activate sensor, and there is your command. Make sure it's selected, not no. Selected, say yes, 10 second. Well, let's do it over 10 seconds and see what happens. See, the first 3 seconds moves, and then the next 4 seconds stops, and then the remaining, it's going to go all the way to the end. Now, when you get to the end, graph it. And I better get this graph. I told you that the fact that you don't get syntax error doesn't mean it's right. This is your input. This is what you want it to be input, and it is your input. Now, if, for example, just hypothetically, if you want to get, let's say, let me rewind this thing and clear my history, close that. Suppose that you wanted to get the velocity of this point, okay, velocity of this point. So you do the usual thing. You're going to go to create a speed and acceleration. The reference product is the space. Point that you want is that tip. Okay. You say okay. Now you go simulation with laws. Over a 10-second interval, activate sensor. The first one is you activated already. It's already yes. The second one is for example, the magnitude of the, magnitude of the linear speed. Actually, let's do x component of it, for example. It's going to be sinusoid. We know that. Okay, so play. One of them is the command. The other one is going to be your speed, velocity of that point. I think the x component, right? I think we plotted the x component, yes. And then when you get to the end, you graph it. There's going to be two curves there. Okay. This is the command. This is what happens to the x component of the velocity over here where it's sitting stationary. It's not moving at all. Obviously, x component is 0. Please make sure you know how to zoom out, sir. I want to be able to read your units. And all the stuff that we have done before, capturing images, saving it, and then plotting something against something else, not against, those are all going to come back on the final exam. Okay? So those, we're assuming you know it and you're on top of things. Okay, good. So that takes care of this problem.